One. Till now what we have seen is general operations in Gambit, operations on vertices and edges. In this lecture we are going to have a look at different operations that we can do on faces. So let's start. So the first thing is like how you can create faces, face geometry. There are different methods of creating face geometry. The first method of creating face geometry is from wireframe. It means you have a set of closed edges, connected edges, which forms a closed loop. So by using those edges we can always form the face. So it creates both real as well as virtual faces. All the edges, the constraint for that is all the edges must be connected to each other and they must form a closed loop. That is the constraint from Gambit side for creating a face using wireframe. The number of edges and peak order are not important, in the sense like you can select the edges in any order that you want. Automatically Gambit will find out how the face should be created, and the number of edges are not important. You can have a closed loop of only one edge. In case of a circular face, the closed loop is only of one edge, or you can have a closed loop of more than one edges. So the number and the order in which you are going to select the edges, that is not important. If all the edges are coplanar, then the face operation is always successful. But if they are not coplanar, a real face, it means if they are not in a same plane, the real face will be created if the edges forms the convex shape, and the planar tolerant face can be created if the edges the edges are not coplanar, but they are coplanar in the given tolerance. We are going to have a look at this operation also. What it needs, the face creation using wireframe, what it needs is it needs the edges that define the boundary of the faces. It needs a face type, which type of face you want to create, and it needs some options specific to the face type. It means if it is a virtual, there are some options that you have to provide. This is a face type real. For creating a real face, different attempts will be made. First one is a standard covering used for simple geometries, and there are advanced covering options also which are available in Gambit, which can create the geometry for very complicated surfaces. So there are three advanced covering operations which are available. For before that, let's have a look at the simple cases where the face can be created. So what I'll do is I'll create a wireframe of the geometry. So again I'm going to use same graph paper. So I want it in xy plane, x minimum -10, maximum 10, and 1 update, y update. I'll see visibility should be up. Now I'll create the vertices. So this is on a single plane, control click. So I got the vertices, visibility off, and now go to a geometry, edge creation, from vertices, straight edge. So I have created a wireframe and they are connected to each other. They are closed wireframe, connected because they are sharing a common vertex, the way I have created. Now this is face geometry, face creation, and the first button is nothing but create faces. So the first button is wireframe. There are different methods of creating faces. We are going to have a look at all these methods. The first method is wireframe. Now in this case the geometry is very simple. All the edges are planar because we have created all the vertices in the same plane. So I'm not going to use any advanced option right now. So now select all the edges. I'll go to pick mode, select all the edges and say apply. If you see the color of the edges is changed, it means it is converted into face. If I shade, you can have a look at the face. So this is the procedure for creating a wireframe. So you go and select the edges you want to create a face out of which. So select the edges. The pick order is not important. Select all the edges and just say apply. So this is the real face which is created. Now there are different options which are available if you go to wireframe. First is in real face also you can give some advanced covering options like initial face, guide edge, and guide vertices. You can also provide a tolerance if the edges are not coplanar. You can also provide the tolerance, or you can go to virtual face and then you can also select the host entity for virtual face, and then you can also select which is the tolerance that what is the tolerance that you want. So this is the advanced covering operations. So let's have a look at advanced covering operations. So there are three operations for advanced covering. What they will decide is they will decide the shape of the face which is going to be created. First option is initial face. In initial face, what we can do is we can give face as a guidance for newly created face, and the shape of newly created face is going to be same as the shape of the guided face that you have given. Guided edge, what it will do is whenever the new face is going to be created, Gambit will make sure that that face is passing through that particular edge because it is acting as a guided edge. The last option in advanced covering is guided vertices. Whenever there is existing vertex, and if you have given that vertex as a guided vertex, then definitely what Gambit will do is Gambit will try to pass that particular face through that vertices. So this is like a cylinder in which there is a hole, and let's say this has created at the time of import. There is some issue about importing, so let's say this face is this hole is created. Now I want to close this hole so that I want to have a watertight geometry. Now if you give only this edge loop for its face creation, the face which is created is like a concave face, but we don't want this. What we want is the new face created has to have a shape of the cylinder. So what I can do is I can give this cylinder as a guided face and this edges as the wireframe loop, and then if I create the face by using these operations, the newly created face will have a shape of the cylinder itself. For example, in this case also, let's say there is a face, then you have created a hole in between, or maybe at the import there is a hole created. If I close this, maybe the shape which is created, that is not proper, but if I give this as a guided face, this shaded or gray colored face as a guided face, then probably the face which is created is going to take the same shape of whatever the guided face is. For example, let me create those geometries. The first geometry is a cylinder with a hole, so I will go to create a volume, primitive volume, say cylinder of height 20, of radius 5, and apply. So I got a cylinder. I want to create a hole in between. There are different methods to do that, but I am going to use the simple one. Again, I will say create cylinder of radius height 10 and radius should be, let's say, 3, and now I want it in centered Y. So centered Y and apply. So I got a cylinder, or I will say positive Y, apply. I got a cylinder. I am going to move that cylinder somewhere else. So move this cylinder in Z direction by, let's say, 5. Correct. Now I got these two geometries. I am going to subtract, or first is I will delete the volumes without lower topology. I got only faces, and then let me delete the faces which are cylindrical caps of this particular face, this and this. I got only a cylindrical face. I got only a cylindrical face with one more cylinder which is interacting or intersecting with that. Now what I will do is I will say split face. We are going to have a look at this particular geometry, or maybe we can also say subtract from this particular face, subtract this face. So we got a cylindrical hole. Let me delete these caps also, and there must be one cap inside. Okay, fine. So this is the geometry. Let's say I have, there is a hole, and what we want is we want the geometry of this hole to be same as the geometry of the cylindrical face. Now if I go to face creation and wireframe, I am not going to give any initial face, so I am just going to say, okay, this is the wireframe of the newly created face, and if I say apply, and now if you shade it, you can have a look at the face geometry. If you see this face geometry, is or maybe let's create a mesh. We can see the discontinuity in that. And this is probably the hole created, the size of the hole is small, so we could not able to see the discontinuity. But what it will do is it will try to create the face which is of concave type. But if I give this as a guided face, let me show you how to give this as a guided face. Now I will go to geometry creation, face creation, wireframe. I will activate initial face, and then let's say this is the wireframe, and initial face, let's say this is the initial face, and I will say apply. I got a new face, and if you shade it, now the face geometry looks very smooth and it is of the same shape that as that of our original face. So this might be visible properly in case of a very curved surfaces. So let me create that first. So again, a graph paper, visibility should be on, apply, fit to screen, front view. Let me create some very curved surface. Visibility should be off, and then edge creation and say nerves, and select all these vertices. I got nerves. Now create a face by sweeping, sweep in Z direction, sweep this edge into vector which is Z direction vector, magnitude should be 10, apply, so I got a face. So I got this face which is quite a curved surface, curved face. Now I want to create a hole in this. So what I can do is again go to cylinder, and let's say the height and radius is same. This is quite big cylinder, so let's create it with one radius, apply. Let me move this cylinder to another location. This cylinder, let's say yes, and let me subtract from this face, subtract from this face, subtract this face. Definitely it will not, because after tool it will try to delete the face. So I will delete the volume first, this volume without lower topology, and then I can go to subtract face, subtract from this face, subtract this face, apply. So I got a hole in this particular object, and this is quite a curved, you can say, a surface. Now let me delete this particular face and this particular face and this face. Now let's say I want to close this hole. Let's say I want to close this hole. Now if I go to wireframe, and if I select only this edge and apply, it has created a face. And now if I shade it, you can have a look at the face. So the face which is created is very bad, because the curvature of this particular edges, the curvature of this edges is so bad that we cannot get the face. So if you see the new face which is created, which is something like this, and it is not at all taking the shape of this original face. Now just if I give, I'll just say undo. Now if I give this particular face as a guiding face, so let's say guide initial face, and let's say edges, this edge again, and this as a guided face. Now if I say apply, now if I shade it, you can have a look at the face which is created, and that is quietly, it is capturing that particular curvature nicely. And now why it has created the same face? Because you have given this particular face as a guided face. That is what you have done. So what you have done is this particular face was given as a initial face for guidance. So that is why it could able to create the geometry properly. So this is the use of you can say a guided face. Similarly you can use a guided edge. So let me create a edge first. So I'll go to create vertex on edge. I'll create, for example, at this location, and at this location I'll create a edge, and then I will create a straight edge between these two vertices. I have created a straight edge between two. Now again I will go to face creation. Now I don't have initial face, I have guided edge. So again these are the edges which forms the wireframe. This is the edge which is guided edge, and I will say apply. So what Gambit does is, whenever you have given guided edge, Gambit makes sure that that face is going to pass through that particular edge. You can have a look at although the face geometry which is created is not good, but you can have a look at that the Gambit has make sure that this particular face which is going to be created, new face which is going to be created, that is passing through this particular edge. Similarly, there is something called as guided vertex. So let's have a look at effect of guided edge and guided vertices. So this is face type real advanced covering operation. So if this wireframe lies on the initial face, then you give this as the initial face, and then if you give this as the initial face and this as a wireframe for face creation, then what Gambit will do is, whatever the new face which is going to be created, that face is going to follow the shape of this particular initial face. So that is what Gambit does. Similarly in this case also, if you give this face as a initial face and again there is a wireframe, then Gambit will make sure that you are going to have a same shape of the face of for the face which you are going to create using wireframe. Similarly in this case also, if you see initial face and this is the wireframe, this is the initial face and this is the wireframe. Now if you give this as an initial face, if you see newly created face is taking same shape of that of initial face. That is what Gambit does if you give initial face as a guided face. Now this is like advanced covering operation, effect of guide edge. So in this case, let's say there is no guide edge and there are guide edges. So this is the effect of faces created. If you see this face has created, it is not properly taking this 90-degree turn, but if you are given guided edges, this one was one guided edge. So if you see here there was one guided edge, here there was one guided edge, and here there was another guided edge. So what Gambit does is, while creating the face, Gambit makes sure that that face is going to pass through this particular edge and as well as this edge. So it has created some shape which is something like this. But if you see here there is some problem, but we can always give this as a guided edge, and again we can rectify that problem. So this is the use of guided edge. Guided edge makes sure that the face which is going to be created, that face is going to have or going to pass through the guided edge that you have given. Similarly, you can give guided vertices, like let's say I have this face edge loop and this as a guide vertex. So Gambit does what? Gambit tries to pass this. So this is without guided vertex and this is with guided vertex. So if you have a look at it, what it has done is Gambit has make sure that this particular face is going to pass through the vertex which you have given. So this is what guided vertex does. So again, advanced covering effect depends on the tolerance value that you have provided. So if you see here, there is something called as tolerance in this case. So there is auto and manual tolerance. So what it does is, tolerance is nothing but how close your geometries are to the, it determines how close the surface of any created face matches the wireframe edge loop that you have given. The smaller value, more closely the surface matches with the boundary loop, and more value it has a flexibility to move the boundary faces from the edges. So if this is the edge loop and it is not coplanar, and if you have given a very tight tolerance, it might happen that the curvature at the end of this surface is very high, because Gambit has or you have given a tolerance which is maybe 0.05. So what Gambit says, the tolerance is very high, I have to, the boundaries of the face and the edge loops that you have selected has to be very close to each other. So it might happen that it will create you can say a curved surface to match that particular requirement. Or if you give a tolerance which is high, then Gambit might create some good geometries, because you have given a flexibility to Gambit of adjusting the boundaries or putting the boundaries away from the boundary edges that you have given. So again, this is the tolerance effect of tolerance. Face created using large tolerance value may create some problem in later Gambit operation, because they are not close to the boundary. There are two ways of specifying the tolerance. One is auto and other is manual. Auto tolerance Gambit will detect what is the tolerance that it has to have so that the face created will be good. Manual tolerance is you can also give your own tolerance. Virtual face is again, virtual face it doesn't have its definition. So if you don't give any host entity, what virtual face is, it creates the orphan entity. The shape of will be always shape of that face will be always a planar face. If you give host entity created parasite, it creates the parasite faces, and the shape is defined by the host entity. That is what Gambit does. For example, in this case, let's say again there is a hole in the cylinder. Now it is a square hole. Now if you have not given any host entity, the orphan face is created. So the geometry of this will be always planar, and if you have given a host entity, the geometry will be a curved surface. This is the effect of host entity. So in case of a virtual geometry, if you see here, in case of a virtual geometry, what I have to give is, I have to give a host. If you have any host, you can give the host. So if I activate virtual, then there is something called as host. Host can be face and volume, and then if you have given face, then what Gambit will do is, it will be a parasite entity, and then it will be based on the initial face, or not initial face, it will be based on the host that you have given, the shape of the particular virtual face which is created. And hide host is nothing but, after creating this particular face, it will hide the host, it will take it to the background. That is what hide host does. You can also create, so this is the way you can create the faces by using wireframe. If you go here, this is the face created by wireframe. You can create a real face. For real face, you can give initial face as a guideline, or guided edge, or maybe guided vertices. Tolerance will decide how the boundaries will be away from the edges that you have selected. If you go to virtual, then you can give the host entity. Host can be volume or face, and the virtual entity which is going to be created, that will take the shape of the host entity. If you don't provide, that will be a parasite entity, and it will be kind of a planar surface. If you activate host, and then if you give face, then you can also give that, okay, I want to hide the host. It means the host, the face which I have used as a host entity, so you can also hide that. And again, the tolerance is same, like how the boundaries of the face will be away from the boundaries of the, or the edges that you have selected. The next method of creating you can say a face is a parallelogram, where it will ask you the vertices. It doesn't need edges. it will ask you vertices. So let me create some vertices for our reference. So let's say this is vertex 1, 2, and let's say this is vertex 3. Visibility should be off. And now face, parallelogram, what it asks is, it asks you origin, inclination vertex and the base vertex. So let's have a look at the meaning of this. This is the origin vertex, this is the base vertex, and this is the inclination vertex. So what it is, the origin to the base will be one edge, origin to inclination will be another edge, and then these remaining two edges will be parallel. One will be parallel to this particular, one will be parallel to this particular edge, another will be parallel to this particular edge. So it creates these two edges using given vertices, and remaining edges will be the parallel edges to the created edges. So what it needs is, it needs the origin, it needs the base, as well as it needs the inclination. That is what the parallelogram face needs. So once you are given this, it will create the parallelogram face. The shape of the face which is going to be created, that will be always parallelogram. So for example, if you go here, I will say origin vertex is, for example, this, the inclination vertex is this, and the base vertex is this. So what it has done is, it has given me a face which is parallelogram. So origin, this was the origin, this was the base vertex, and this was the inclination vertex. So origin to base is one edge, origin to inclination is another edge, and these two edges are parallel to them. So that is the way Gambit has created the face. So this is one more method of creating face, parallelogram face. So again, as I said, origin, inclination and base, you can also provide the label. So in this case, we don't need edges. It means, in the sense, whenever you have vertices, and if you want to create the parallelogram, we need not to go through edges. Using vertices itself, we can directly go for a face creation. So this is again a polygon face. It creates the planar polygonal face defined by set of 3 or more existing vertices. 5 or more vertices must be coplanar. Selection order is important. What it does is, it creates the polygonal face. It means the face of, you can imagine the face which is created by a closed edge loop joining the vertices that you have selected. So the main constraint behind the polygonal face is, at least 5 vertices must be coplanar, because it has to decide the geometry of the face, and if all the vertices are not coplanar, then it will be very difficult for Gambit to fit the surface out of it, to fit the surface which is passing through all the vertices. So at least 5 vertices must be coplanar, and the selection order is important, in the sense, the way I am selecting vertices, it is also important, because internally it is going to create the edges. So if I select this as the first vertex, this as the second vertex, third, fourth, fifth and sixth, seventh, it is going to create these edges. Now same vertices, if I select this as first and second, and then third, fourth, so the sequence of edge creation is same as the sequence of the vertices that you have selected. The sequence of edge creation is same as the sequence of the vertices that you have selected, and again the geometry of that will be based on the geometry, based on the sequence of the edge creation. So this is the face, polygonal face. What you have to give is just the vertices. So again I will delete this particular face, and I will just delete these edges. I just want vertices, so I got vertices. Now face, if you go here, that is nothing but polygon face. Right now I have 4 vertices, so first, second, third and fourth. If I say apply, if you see, you got this polygon. Now if I select first, second, third and fourth, it doesn't make any sense. What it will do is, it will not create, because I have selected this as the first and this as, what I have done is, I have selected this as the first vertex, this as the second vertex. So the first edge created is going to be this, then this as the third vertex, the second edge going to be created is this, and this as the fourth vertex, the third edge going to be created is this, and then this. It doesn't make any sense. The face which is going to be created is intersecting face. So let me create one more vertex, because this thing looks similar to that parallelogram, but let me create one more vertex. So let me create a vertex somewhere here, and maybe here, and maybe here, and then I can go for parallelogram. So face creation, parallelogram, not parallelogram, polygon, and select the vertices. So first vertex, second vertex, third vertex, fourth vertex, fifth, sixth, and seventh vertex. So what I got is, I got a polygonal face. So this is the way you can create polygonal face. Now if I select the vertices in different way, first vertex, then second vertex, then third vertex, then fourth vertex, if you see, what I got is this. So depending on the way you are selecting vertices, the geometry of the faces will be different. So this is nothing but create polygon given by using vertices. So again, it doesn't need edges, you can directly go for polygon. Internally it will create the edges depending on how you are going to select the vertices. So the next method of creating face is create a circular face from vertices. Again, we don't need edges. So what internally it does is, first it does create a circular edge, and I guess we have seen what are the ways of creating circular edge. So first it creates circular edge out of vertices, and then it goes for circular face. So all the three vertices that you are selecting must be coplanar. That is the constraint from Gambit side, that non-coplanar vertices it cannot fetch the surface. So you have to create the coplanar vertices. So method 1 is center point and 2 endpoints, method 2 is 3 points. So that is the two methods for circular face. So let's have a look at these two methods. As I said, the first method is center point. So what it needs is it needs a center point vertex, and it needs 2 points on the edge. Once you have given these 3 vertices, it creates the circular edge, and then it creates the face out of it. That is what it does. The second method which is here, the second method is you give the 3 points on this, you give 3 points. What Gambit does is, Gambit creates first the circular edge using these 3 points, and then it fits the circular face using these 3 points. So that is the method for creating a circular face using vertices. So let's have a look at it. The first method, again, circular face, the center point and 2 points on the edge. So let's say this is the center point, and these are the 2 points on the edge. Apply. So the points selected not share a common radius, and that is true because in this case the vertices should be at the same distance from the center point. So definitely I cannot use this method, but definitely I can use this method. So again, first vertex, second vertex, and third vertex. So what Gambit has done is, it has created the edge, circular edge, and then it has created a circular face out of it. So the first method, the points must be equidistant from the center. The second method, it fits the circle passing through the vertices that you have selected. So this is the method of creating circular face. So next method is creating ellipse. Again, it is same as creating elliptical edge. First it does what? It creates the elliptical edge using the vertices, and then it creates the face out of it. So elliptical edge is created. What it asks is, it asks the center vertex, it asks you the vertex on the major axis, and it asks you vertex on edge. So let's say vertex on edge, apply. So it creates the elliptical face. Again, center vertex, again major vertex, and on edge vertex. It creates the elliptical edge first, and then it creates the elliptical face out of it. So that is nothing but face, elliptical face. In this case, by default it creates the elliptical face of 360 degree, but you can always activate the start and end angle, and you can control that. So center vertex, major vertex, then on edge vertex, and the start angle is 0 and end angle is, let's say, 180. So it creates this elliptical face. So 0 to 180 and elliptical face. So center vertex, so I have given this as a center vertex, I have given this as the major vertex, and this as the on edge vertex. So it has created this elliptical face of 180 degree. So that is what Gambit does, is nothing but elliptical face. So let's have a look at those operations. Elliptical face, it creates the face that represents a section of a full ellipse. It needs center, major and on edge vertices. It determines the size and shape, must be coplanar, and start angle and stop angle, you can provide the start angle and end angle. So what is it does is it creates the elliptical face by using with this elliptical face of this kind of geometry: center vertex, on edge vertex and major vertex. These are again very good options available in Gambit: creating a skin surface and creating a net surface, and creating a surface of using vertex row. And if you remember, at the time of ICM input, vertex creation operation, ICM input, we also seen that there are some advanced options to create the faces, and these are these options. What it does is it creates the skin surface. It creates the surface consisting of one or more face from set of ribs that defines the shape of the surface. So we will define rib first. What is rib? Rib is something like connected edges to each other. For example, if this is the thing that you have, like you have edges which are logically parallel to each other. They are not parallel, but they have a same, you can say, direction. They are not intersecting to each other. So these are called as ribs. Ribs are like if you want to create something like a wooden structure or wooden table. So what you do is you on the base you define the structure of the table by using ribs, and then you put wooden plank on that particular ribs. So same thing happens in this case also in Gambit. What it does, these ribs are nothing but the edges, and what Gambit does is Gambit passes the surface which is going to be created through those ribs. So in a simple case, the rib is nothing but the edge, but in some complicated cases the rib might be the connected edge loop. We'll have a look at it. So in this case, this is actually one rib, this is second rib, this is third rib, this is fourth rib and fifth rib. If you are given this set as a ribs to face creation, what Gambit does is Gambit fits this particular surface, and that surface is going to pass through this particular ribs, and definitely the geometry is going to be based on the geometry of these edges. Again, they are planar or coplanar, are they coplanar or non coplanar, and something like that. So what Gambit does is, by given the ribs, set of ribs, Gambit creates the surface out of it. That is what Gambit does. So rib can consist of either a single edge, the case which we have seen as a single edge, or set of connected edges. The type of rib specifies the geometry of the face created. If all the ribs are single edges, it means if all the ribs are formed by only a single edge, only one face is going to be created. If the rib is formed by more than one edges which are connected to each other, then number of faces will depend on how many edges are there. So we will also have a look at it. Shape of the face is interpolation through all the specified ribs. Ribs is in simple case all the specified edges. So this is the way the face is going to be created. For this face, this is like a four-sided faces. This will be always a four-sided face. The first and last ribs are the two sides of the face. The first and last rib is the two side of the face, and the two edges continuous curves fit through the end point vertices. That is the two edges of that particular. So in this four-sided face, the first two edges are nothing but the first rib that you have selected and the last rib that you have selected. The remaining two edges are nothing but a continuous curve fit through end point vertices. It means whenever you select the ribs, there is always a end point vertex of that particular rib. So the third edge is nothing but the edge, continuous edge passing through these vertices, the endpoint vertices, and the fourth edge will be again passing through the endpoint vertices. So this will be the fourth edge. So this is nothing but the four side. The first side is the first rib, second side is the last rib, third side is the start vertex of every rib, and the last side, fourth side, is nothing but end vertex of the every rib. So that is what the four-sided vertex four-sided face will be created. Ribs with a single edge, correct sequence of the ribs is important. Incorrect sequence fails to generate the face, or it creates the intersecting geometry, which is invalid, definitely invalid geometry for gambit. It means the way you are selecting edges, if I selected this as the first edge, second rib, third rib, fourth rib, and fifth rib, definitely gambit creates the surface. But imagine that you have selected this as the first rib, this as the second rib, then this as the third rib, fourth rib, and fifth rib. The way it is going to create, so if you see, this will be a last edge, this is the last rib, so end edge of the one edge of the face created. Again this will be a first rib, one edge of the face created, and these edges, if you see, these edges will be from the start point of the first rib, then start point of the second rib, then it will be third rib, and then it will be something like this. Similarly here, the start point of this, then this is the second rib, this is the third rib, then fourth rib, and fifth rib. If you see, the geometry created is like a twisted geometry. So the sequence of selecting the ribs will be very important in creating a net surface. So what you do is, you select the ribs in such a way that it doesn't form the intersecting loop, and you select the ribs in the way you want to create the surfaces. So this is the proper sequence of selecting the ribs, or you can also select this particular sequence. That is not an issue, but this rib and then this rib is not allowed, or this rib, you should make sure that it is not going to create the intersecting faces. So this is the correct sequence is important. Now the rib with the connected edge options, what it does is, it creates the number of faces depending on how many number of chain loops are there. So in this case, what we have to do is, we have to first activate the connected edge option. That is the first thing we have to activate. It creates the single face by connecting number of faces. The face created depends on the number of internal points that you have. For example, let's say this. Now in this case, if you see, this particular first rib is made up of a single continuous edge. The second rib is made up of, this is one edge and this is another edge, and this is connected through a common vertex, this common vertex. So if you see this edge and this particular rib, which is a rib, you can say B, this particular edge is, or this particular rib is formed of two closed, or two edges, loop of two edges which are sharing a common vertex. They are connected edges. Similarly, if you talk about the rib C, that is made up of edge 5 and edge 4, and they are connected to each other. So these ribs are not simple ribs. These are these ribs are formed using the connected chain loops. Now what gambit does is, gambit doesn't create a single face. What it does is, the number of faces it is going to create, the number of faces will be the number of internal vertices. These are called as internal vertices. The number of internal vertices plus 1. So what gambit does is, gambit fits the surface using this, and then what gambit does is, like depending on how many internal vertices you have, gambit creates those many faces. So in this case, what gambit does is, whenever it finds the internal vertex, it creates the edge here, then the edge which is passing through that vertex, the edge which is passing through this vertex, the edge which is passing through every internal vertex, it will create the edge, and the number of faces created will be number of edges, or number of internal vertices plus 1, because one face anyway it will create even if there are no internal vertices. So for example, let's have a look at those particular operations. Now let me create some edges. So before that I will create vertices. Now let's say this visibility should be off, then edges, create edges and say nerves. This is the first vertex, second vertex, one edge, first, second, third, another edge, third edge, third edge, and let's say this is fourth edge, and these are the ribs. Now let me delete the unwanted vertices, the vertices, construction vertices. So if you see, now every rib is made up of only one edge. Now I can go to face and I will say skin surface, and right now I don't have connected edges, so I will select this edge, this edge, this edge and this edge, apply. I don't have start vertex. We will see what is start and end vertex. So if you see, what I got is, I got the face. So this is nothing but skin surface. Now let me split this edge, into two edges. So for example, this edge into two edges and this edge into two edges, and now they are not simple ribs, they are formed by connected edges. So first we have to activate connected edges and then select the edges in proper way, first edge, second edge, third edge and fourth edge, and then remaining ribs, apply. I don't have start and end. If you see, what it has done is, here there was one vertex, so it has passed this, here there was one vertex, so it has passed through this, and then it has passed through this. So the number of faces created, 1, 2 and 3, there were internal two vertices, so it has created 2 plus 1, 3 faces. So that is what Gambit does if the ribs are formed of connected edge chains. So that is what but in that case, what we have to do is, we have to activate these connected edges again, select the edges. The sequence will also matter. I will tell you what is the sequence. So the first rib, second rib, third rib and fourth rib, and then remaining edges. No start vertex, no end vertex, apply. So it creates the face. So this is the way it will work. So I will tell you what is the effect of selection and all. So in this case, what is the rule is, you have to at least select one edge from every rib. That is what is the rule, and remaining edge sequence will not matter. It means, in this case, if you see, in this case the first edge is only one, first rib is only one edge, second rib is made up of two edges, third rib is made up of again two edges, fourth rib is made up of 1, 2, 3 edges, and the last rib is made up of two edges. Now in this case, the sequence of selection should be at least one edge from every rib. So as this is only a single edge, I will say 1, then it can be 2, 4, 6 and then 9, and remaining doesn't matter. Remaining you can select in any way you want, or the sequence could be, remember, every one edge at least from one rib. So again, this is 1, you can say 3, you can say 4, you can say 7, you can say 9, and remaining will not matter. So that is nothing but the general you can say sequence of selecting edges if they are closed chain is, you at least select one edge from every rib and remaining selection will not matter. So that is the rule. So the number of faces which are created, the number of faces are equal to number of internal vertices plus 1. So that is nothing but skin surface. There is something called as start vertex and end vertex. What you can do is, you can specify Gambit that you create the surface and the end point of that surface will be this end vertex, or the start point of the surface will be start vertex. For example,